Hello Year 12 and welcome to the fourth video here for our sixth topic. We were looking at the sine rule in the last question, the last exercise, and now we're going to look at the sine rule in a little more detail. We're going to use it instead of finding a side to find an angle. Now it doesn't change our working very much, but we are going to use sort of a variation on the formula that we used last time. Let's jump straight into it. Here I have, there's my unknown. I've got the side opposite that unknown, that's good. And I've got an angle here, and I know the opposite side there too. So this is fairly straightforward. So we start by saying that sine theta over 20 is sine 15 over 9. Okay. Previously we had put the side over the sine of the angle, right? We said A over sine A equals B over sine B. But it's equally true to say that sine A over A is sine B over B. It just works out a bit neater if our unknown is in the top left. So, a little bit of rearranging here, and I get sine theta is 20 sine 15 over 9. Theta is the inverse sine of that. 20 sine 15 over 9, and theta equals, write a calculator, do your work. So 20 sine 15 equals, divided by 9 equals, second function sine equals, and to the nearest minute, 35:07, right? 37 seconds rounds up to the next minute. So that's 35 degrees, 7 minutes to the nearest minute. Now, here's another example. I've got this nice pair here, that's good. This is the angle I want to find. I don't have the opposite side. That's a problem. I've got this side here. Now, this side here is best used to find this angle, right? And that's what we're going to do. Much easier to find that angle than the side, this stage. So I'm going to give this a new name. I'm going to call that phi there. Right, draw that on the diagram. I'm going to calculate phi. Then I know that my three angles here will add up to 180 degrees. So once I know two of them, I can find the third. So we're going to write this. Sine phi over 9 is the sine of 106 over 14. That means that phi, we'll say sine phi equals 9 sine 106 on 14, and phi is the inverse sine of that. (14), and my calculator will help me out there. So 9 sine 106 equals, divided by 14 equals, now the inverse sine of that is 38:10. Brilliant. That's all good. It's not quite my answer yet though, is it? Because I need theta. So we know that theta equals 180 minus 106, and also take away the 38:10, and easiest to do this on the calculator again. 180 minus 106 minus my previous answer, and I get 35:50. Rightio. Now, we do need to look at another situation here. Consider this. What's the sine of 30 degrees? Grab your calculator, check it out, do that now. Sine of 30 is 0.5. What about the sine of 150 degrees? Sine of 150 degrees is also a half. That's a bit curious. So, when I do the inverse sine of 1/2, my calculator tells me 30. But 150 would be a perfectly acceptable answer there as well. Right? There are in fact an infinite number of answers to that problem, but your calculator just gives you the smallest one. So, it is possible for a triangle to have an obtuse angle in it, right? Like this triangle here, right? See this triangle here? It certainly appears that this angle here is more than 90 degrees. And your calculator, when you do an inverse sine function, won't give you that answer. Right? The calculator will give you an acute answer, an answer less than 90 degrees. Now, if a question doesn't say that there's an obtuse angle, and it doesn't look very obvious that it is, then just give the acute angle. But sometimes the question will say theta is obtuse, calculate the size of theta, in which case you need to take the answer provided by your calculator and take it away from 180 degrees. Right, that's all. Do the sine rule as before, but take your answer away from 180 degrees to get the obtuse angle. So here we go. Fairly neat, right? Opposite sides and angles. And I'm going to say that sine theta over 10 equals sine 22 over 5. It's all good. So sine theta is 10 sine 22 over 5. That means that theta is the inverse sine of 10 sine 22 over 5. And theta equals, write a calculator. So check this out. We'll go 10 sine 22 equals divided by 5 equals this, the inverse sine of that, equals this. But that's not the answer that I want. So now I'm going to say 180 minus my last answer, right, is to the nearest degree is 131 degrees. Righto, like that. All good? Take your answer, right, use the sine rule as before, but because we were told it's obtuse, take your answer away from 180 degrees, and that gives you theta where it is obtuse. That's it for the sine rule, either for calculating sides or angles. If you've got any questions, please jot them down, and I'll see you in class.